Welcome to the Freaky Fauna Files podcast. We're your hosts,
the chicken,
and the egg, where the eternal question remains, which one comes first?
Hi, I'm the chicken, and I'm going first today. And for a special Halloween episode, rather than focusing on a particular region, we're going to discuss 4 animals that outshine them all. Or should I say, outglow them all? It's time for some spooky bioluminescence.
And in this particular episode, we're going to branch out to more than just some freaky fauna. We're hitting the big 3. Freaky fauna, freaky flora, and freaky fungi.
Oh my.
You know, animals, plants, and shrooms.
And if you're not already following us on social media, you can find us at Freaky Fauna Files, and we're on Insta, TikTok, YouTube, and Facebook. So please check us out for pictures of the freaky organisms that we will discuss today.
Let's go.
Boom. 1 tide, 2 tide, red tide, blue tides. Our first organism is going to have to do with a reoccurring phenomenon that happens along many shores, and it is quite beautiful to see, but not so beautiful for the sea. I know. I was proud of myself. But I'm talking, specifically about blue tides. And these are when the waves will boast a ghastly blue hue as they crash along the shore. It's really stunning to see. Yeah, it's beautiful, beautiful. Actually, we had it in Galveston quite often this previous summer.
What? When?
Yeah, I would say like at least 2 or 3 times off of Bolivar. I got like little notices on Facebook about it. Yeah. So this miraculous sight, it's actually due to bioluminescent phytoplankton species, most often caused by sea sparkles.
That's cute.
I know, an adorable name for them. Adorable name. Sea sparkles, they're scientifically known as Noctiluna scintillans, and it is a dinoflagellate that can exist either in green or a red form. Okay, so they've got 2 different colors. So it was considered a jellyfish until around 1873 when Ernst Haeckel changed them to be classified with the dinoflagellates.
And what's a dinoflagellate?
A dinoflagellate is just a microorganism that essentially has 2 little flagellums.
Love that word.
I do too. But it essentially talks about how they move. And Ernst Haeckel actually is not only a really well-known scientist, but he's also a really well-known artist as well.
Pop off king.
So he is known for his really famous piece of art that demonstrates a whole bunch of different styles of radiolarians and different microscopic organisms. And he has a nudibranch one that I have in my house. Yes, I love it. It is super beautiful.
Wow.
It's my favorite. So, sea sparkles, they are super duper small, and I mean microscopic, like 400 to 1,500 micrometers in length microscopic.
Waist was snatched.
Yeah.
Tiny.
Snatched. They are planktonic, which means that they are unable to swim, and they just kind of float along in the current.
Unable to swim?
Yeah, kind of like jellies. You know, there's planktonic and then there's nectonic. And nectonic creatures can swim freely, do whatever they would like to do. And then you got the planktonic that just kind of are at the mercy of the ocean, the waves and the current. So the green and red forms, as I mentioned, they are actually derived by a pigment. They're derived by the pigment that is inside of their vacuoles. And the vacuole, as a refresher, is a membrane-bound sac that is within these organisms. Typically means that they are heterotrophs that will compete with copepods to eat other phytoplankton. And then we have our green boys, and they are green because they actually have a symbiont that is photosynthetic, and that causes them to be green. And it also causes them to be either autotropic or photoautotropic, which basically means that they're able to convert abiotic or inorganic compounds into organic compounds that they're able to use for nutrients. So they can basically be fed.
They're basically built-in besties.
Yeah, they are built-in besties. They're the best besties because they give them food.
Keep me alive.
They keep me alive, yeah. So I've talked red, I've talked green. So where does this blue come in? So sea sparkles are the main causes of the infamous red tides that you may have heard about. And at night, these red tides actually turn blue. Okay. And before I get into that a little bit more, I do want to talk about red tides. So red tides, they're incredibly toxic and terrible for the environment. Mm-hmm. And they are typically caused by a proliferation of these sea sparkles. So it's when
sea sparkles bad?
Yes, whenever they are really happy, whenever the environment is great for them, they sparkle, and the sparkle is not good for everybody. Not good for everybody. So the sea sparkles themselves are not toxic and cannot produce toxins, yet they have been linked to massive mortality of fish and marine inverts all over. Yeah, so they be killing them.
That's not my problem.
They just be killing them. They're like, I'm thriving. It doesn't matter that you're not.
I'm thriving.
I'm thriving. If they can't produce the toxins, how are they dying? They're abundant, so whenever there's so many of them, it actually will block out the light. And this kind of has a trickle-down effect, and the dissolved oxygen will deplete, and ammonium will actually begin to accumulate in really high quantities. And this is a big no-no for the fishies. It's essentially suffocation.
Spicy water.
Yeah, it's asphyxiation for any organism that is below the bloom. Mm-hmm. So it's really not good for really the environment in general. So how do these red tides turn blue? Well, when N-scintillans are disturbed or experience any type of mechanical stress, they produce luminous flashes. Well, shit, that's better than hot flashes. I wish when I had stress, I would fucking just glow.
Glow.
Just glow.
Gorgeous.
Like, I feel like that would be exposing too, though.
You know what I think of? I think of Fiona, Shrek's wife. Whenever she's turning into the ogre for her final form. She's like, that glow.
That like yellow hue that comes out.
Nostalgic yellow hue glow.
Yes. That is what's happening. That's what's happening, essentially. The flashes themselves are caused by a reaction between luciferase and luciferin, which is a substrate and an enzyme that will work together produce the light. The two will react with oxygen to form an oxidized complex that then causes the luciferin to emit a photon. And this photon is where that kind of flash comes in. So these reactions are all happening within the sea sparkle. And when a boat or a wave or a person comes into contact with this sea sparkle, there's enough deformation there that will actually cause the pH of the organisms to lower, which causes the reaction to happen. So it's like they get bumped and they're like, don't touch me.
Stress.
Glow. It's like blinds the creature. That's why it's blue. And during the day, it's kind of harder to see this happening, but at night, it's a lot more pronounced. So it's kind of happening all the time. In regards to blooms, there is a lot of variability when it comes to kind of how long they last and specifically the duration of the bioluminescence. So if you ever get the chance to actually go and see a blue tide, I would recommend it. It's quite surreal to look at the glowing blue waves, but I do not recommend going into it at all.
Spicy water.
It's not necessarily harmful for us, but it can be harmful for like our pets or other creatures out there. So that's all I've got for my blue tides.
Those are pretty cool.
Yeah.
Science is pretty cool.
Science is pretty cool. I always knew that there was a microorganism that was causing the blue tides. I was interested to find out what exactly reaction was causing that. The luciferin and the luciferase I thought was pretty interesting.
Some good chemistry for you.
Good chemistry. Yes, some good biochem. All right, let's pass it off to the egg.
I get the absolute pleasure of talking about mushrooms today.
Ooh-wee.
We're going to talk about shrooms, and I'm super excited.
Guys.
In order to do my duty to this podcast, I must start out by addressing the fact that mushrooms are not freaky faunas nor freaky floras. That would mean it would be an animal or a plant, but they are, in fact, a fungi. So there's your party fact.
Yeah.
Fungi, mushrooms, mold is not in a plant or an animal.
No,
It
they
is
are
its
not.
own
They are not. They are their own little weird sect of
Life.
Yes.
Yeah, so mushrooms are more closely related to animals than they are plants, which explains why they have a more meaty taste, it might seem.
Yeah, I've heard like lion's mane and stuff taste like meat or like chicken or lobster or something like that.
Yummy. Of course, they're more commonly found growing on the ground or on trees because they have a similar root system to plants. However, instead of roots, they have mycelium, which is a fancy word for like a vast network of communicating wires that support like these giant communities of shrooms.
Yeah, I heard that actually
Acres, miles, square miles wide.
That anywhere you walk, really anywhere you walk, you are stepping on some type of mycelium. The networks are so crazy.
Yeah.
They
We
just
are
like
all
sending little
connected.
messages like meh. Like how you doing?
They yapping.
They yapping.
They certified yapping.
That's so funny. They're yapping.
So most of the bulk of what a mushroom really is that mycelium, so they're underground. Only certain species actually form a physical shroom top. You know what I mean?
Oh yeah, like the little thing that pops out.
Yeah.
The typical thing that we eat.
Most of them are just underground mycelium. There's like actually close to 1.5 million species of mushrooms.
Holy hell.
So yeah, most of them are just underground systems.
So we have no idea.
Oh yeah. Oh yeah.
What the heck? I'm not going to sleep tonight.
Good. It's a spooky episode.
Yeah, I was about to say, that's spooky in and of itself. There are millions of fungi creatures
All around you at all times.
at all times.
Spooky.
They're listening. They're talking about you under your feet.
So, shrooms most of the time only grow when it's time to spread their spores. And spores are pretty much synonymous to pollen in that, you know,
It's like the reproductive thing.
the plant hopes to use wind, water, or another animal to pick it up and transport it to a new place. And so that's why mushrooms are often scavengers, because that's a good way to spread your spores, is because that attracts, animals.
Yeah.
And you can rub up on them.
That makes sense. That makes sense. Mother Nature has some weird ways of spreading their seed, for sure. One really annoying are those stupid spikes. You know what I'm talking about in like the grass? Those like spiky things that get stuck on your socks, stuck on your
Spurs.
shoes. Yeah, those little spurs. All over where our new house is. All over.
Oh, that
All
sucks.
over.
What about
Yes.
Meaner Beaner?
Well, I just have to watch her when she's walking. And like if she does a weird walk, I'll like inspect the paws. But yeah, no. Fuck Mother Nature sometimes. Gosh. Anyways, sorry.
So, even though we got a spooky episode, most mushrooms are actually harmless. They can be decomposers, scavengers, parasites, or they can be poisonous. And then
Very
the grand
useful.
finale, they can be psychedelic.
Ooh, the good ones.
So, in terms of species that actually glow, there's only about 70. So, are you ready for the contenders? I've got a list of names that I just thought deserve to be said out loud.
I do. I am
These
ready.
are, I present, the names of shrooms that are bioluminescent. First, we got the bitter oyster, because that one is...
My spirit
one of-
animal.
Sure. That's what you choose to
I'm a bitter oyster.
They are not the edible kind, actually. I know oyster mushrooms. Oyster mushrooms are, but these are not edible. They are those fan shelf-looking ones that grow on the side of trees,
Oh, I know which ones you're talking about.
and they are the brightest and the spookiest on the list.
What
of
color?
Bioluminescent.
What color are they? Like blue, green, red?
Yeah.
Yeah.
Next one is
Yeah to all three?
what?
Yeah to all three colors.
Maybe they are. Maybe he's just the prettiest and handsomest of boys.
Maybe it's just the rainbow.
Disco. He flashes them.
It's the ally mushroom.
Did you hear me say he was the brightest on the list?
He is the brightest on the list?
All bioluminescent species. Mr. Bitter Oyster, your spirit animal. So that's another reason why he could be your spirit. He's the brightest on the list. Your glow continues.
My glow continues.
And then we got little ping pong bats.
Excuse me?
Those look like little lily pads. They're teeny tiny, maybe like quarter sized on a stem. Who names these?
I don't know, but I would like to name one. Little ping pong balls.
Dude,
Wait, bats, not balls.
Did I say balls?
No, I think he said bats. Okay. I think I heard balls.
Little ping pong bats.
Bats.
We recently had to find new homes for some kittens, and one of the families was 2 little girls, and they named the kitten...
Oh, no.
Wait, hold on. Itty Bitty Honey Bun.
Itty Bitty Honey Bun. Itty Bit for short.
So to little ping pong bats, I raise you Itty Bitty Honey Bun.
I don't know if I can top that one.
The next one is a lilac bonnet, which is a typical mushroom shape, but they're purple. So how cute.
That sounds pretty.
So her bioluminescence is limited to the mycelium, so you don't get to see it.
Oh, well, that's shitty. What's the
She's
point?
Still purple, okay?
What's the point?
She still glows, so if you dig her up and you happen to see, her glow.
Her glow.
Eternal light mushroom, and these are tiny cap-shaped mushrooms with really long curly stems. It's super weird, like a vine.
Did you say cat-shaped?
Capped, like
capped
mushroom.
Like a cap. Got it.
But their stems glow constantly year-round.
Oh, so we can see them.
Most of these are seasonal. Yeah.
Cool.
The bleeding fairy helmet, most notable for bleeding red or purple when they are cut.
These names are gonna take me out.
Fairy helmet.
Bleeding fairy helmet.
Yeah.
It sounds like an anime name.
Yeah. So most of these continuously glow for days to attract insects that will spread their spores, but like the last one, eternal mushroom glows for all season round. The glow most likely comes from underneath the umbrella portion, not necessarily glowing on top.
Oh, yeah.
Right?
The part that they
gills.
like print.
Yeah, the gills that's underneath. So, you had mentioned luciferase and luciferin.
Yep.
Those also come into play in our shrooms.
Cool.
So, yeah, it takes a lot of energy for these little dudes to produce light, and that's why most of them only shine at night, where they can shine the brightest.
Ooh.
And, yeah, that's all I have for our shrooms. Stay tuned for the safe zone, because I'm gonna dump on you.
Oh, fantastic.
I'm very excited. So excited.
I'm excited. So, I guess until then, I will talk about ctenophores, or the little comb jellies. So, ctenophores are a phylum of marine invertebrates that can be found all over the world, from -2 degrees Celsius to 30 degrees Celsius. They can even be found on the surface all the way down to about 7,000 meters. So, they are really very well dispersed throughout the world.
Dispersed and diverse.
Yeah. So they are also very old. So old that biologists have proposed that they are the second oldest animal branch, right behind the sponges.
Oh,
right behind the sponges.
True.
Sponges are the most basal organisms really ever, right? And so scientists are like, okay, comb jellies are the second oldest. So it's like sponges, comb jellies, and then some other like cnidarians are in there. All right. It's insane how basal of an organism they are. And there's really only a few differences between the two phyla, and that is that comb jellies have muscles, nervous system, sensory organs, and a few other features that make them just a little bit more complex. So they're basal, but not like basal. They're not like
medium basal.
Yeah, they're not like
the
very start. They're not the very start. They're baby basal, yes. Comb jellies look like see-through jelly sacks.
Love that.
That was the best description I could think of. And vary in size from like a few millimeters all the way up to 1.5 meters or 5 feet. Yeah. Ew. The biggest one is actually called the Venus girdle. And I know.
What a name.
I know. These names are just crazy. But the Venus girdle, it has a ribbon-like body. So that's kind of how it gets that 5 feet. So when you see it, it may not be like a 5-foot shark, but it is still 5 feet long. It just might be coiled up a little bit. So comb jellies, they'll consist of 2 main layers with a gelatinous middle layer called the mesoglea. And to move around, they have what is called cilia, which are little hairs that will line the entirety of the body. They are specifically organized into 8 strips called comb rows that will be largely responsible for whatever direction they are going to be going in. So most of the time, they will be beating in a way that causes the organism to swim in the direction the mouth is eating, which is very convenient.
It's like little propellers.
Yeah, just like if you're eating a little microorganism, it just pushes you further onto that microorganism. I know, yeah. If it saves me some energy, why not? They can actually reverse the direction their cilia beats, which I think is pretty cool, and use it as a type of defense mechanism to escape any predators.
What?
So they could just be like, psych, boop. They could also accelerate nearly 6 times their normal speed.
Oh, fast boys.
Fast boys. So not only can they just like skirt in reverse, but they can go very fast. So they're quick little boogers.
Wow.
Quick little boogers. That's exactly what they look like.
Yeah.
Yeah. Almost all ctenophores are going to be predators, minus a couple of juveniles that are actually parasitic. And they're going to be feeding on particulate organic matter, fish larvae, copepods, etc. Just little tiny guys that they can do. And the comb jellies have colloblasts, which are these like sticky little tentacle-like things that allow them to adhere to the prey. And once prey is swallowed, they have enzymes that start to liquefy them, kind of like how spiders liquefy their insects.
Bro.
Yeah, so enzymes begin to liquefy them in the pharynx, and then that slurry is then pushed through their digestive system via the cilia.
That's what our fireflies do.
Oh, for real? Oh, spoilers. It's pretty cool that they have cilia really all over their body, too. So not only is it outside and used for locomotion, but it's also on the inside helping move things around. So just all over locomotion. Oh, and my favorite part before I get into the glow is that ctenophores have what is called a transient anus.
Oh.
Yes, which means that it appears only during defecation. So they're real shy. They're real shy.
Only appears. If they're see-through, does it just...
It's just
only
not there.
come together in form?
Yeah.
When it's ready?
Yeah, it only comes whenever it's needed. Like imagine like you would have a Barbie doll butt all the time. And then it's only when you need to go does a little thing form. And it's like, it's time.
It's time.
That would be quite beautiful, actually.
Yeah.
That would be very great. What if you have to fart, though?
It would make way.
It would also pop up then, too.
Yeah.
You know?
It would make way.
Yeah, so that was one of my favorite facts about the ctenophores. Wow. Yeah, I love them. So for their bioluminescent, most comb jellies are going to be bioluminescent, and they will be emitting like a blue-green light. However, not all of them do this. The ones that are often seen on the surface are going to be colorless and are not going to emit too much light. Although, when you look really closely, you can see light reflecting off of the cilia.
That part's so cool.
Oh, it's intoxicating.
Yeah.
Like, I'll be on a dive and I'll just be sitting there trying to cup the cilia in my hand just so I can have, like, a background to it. Like how people do it on videos, you know, when they're showing a product. Yeah, like I'm doing that to the cilia. Or not the cilia, the comb jellies. And, yeah, you get lost.
It's really
Because
cool.
they beat really... It's very mesmerizing. And then you also have the rainbow on top of it. Yeah, awesome. But that's not technically bioluminescence. So
Just reflection.
just reflection, just
Rainbow fish.
magical light. Yeah, magical light.
Throwing shade on rainbow fish. You read that book?
Rainbow fish?
Yeah.
Yeah. Yeah, definitely. Who has not read Rainbow
Got
Fish?
offended. Of course.
Yeah, yeah. Who
Rainbow
am I? Who am I? Yeah. That's my brother. Okay. The magical component in them that will actually allow them to glow is called ctenophores. And this is a light-emitting chemical that is often used by a few other major groups of deep-sea animals.
That's a very threatening word.
Yeah. ctenophores?
Yeah.
Yeah, it sounds like a bomb.
Yeah. That's what
It's
I
like
was gonna say.
TNT. Yeah. It's like the next, what is it? CNT. Ctenophores. But, so with ctenophores and other animals using it as well, the biggest difference comes from that most of the other bioluminescent organisms have to eat other glowing organisms to gain this chemical. Thief, right? They're not just magical on their own. They have to steal it, essentially.
Yeah.
However, there are at least 2 species of comb jellies that are able to conjure up this chemical inside of their bodies all by themselves.
Oh.
Which is groundbreaking.
No built-in bestie?
No built-in bestie. Nope, they're just raw dogging it themselves. They're figuring it out. The 2 species that have been proven to do this are the awesome sea walnut and the northern comb jelly.
The awesome sea walnut?
Okay, well, that was my own adjective.
You said it so confidently. I really thought that was a part.
Because they're awesome. They're awesome. The sea walnut is also, I believe, found here in Galveston. It's not supposed to be, but I believe it's an invasive species here because I have for sure seen them out. So, in order to prove that they were producing this chemical on their own, scientists worked with the Monterey Bay Aquarium, and they were able to produce several generations of comb jellies that only ate animals without the coelanterasine. And despite this, the comb jellies were still able to glow. So it proves that they are able to keep doing it despite not getting it from an outside source.
Wow.
Which is pretty significant. It's pretty significant. And it's a big deal because the ctenophores that are able to glow can now become a source of glow for other organisms that feed on them in the deep sea.
So their thievery paid off for others.
Yeah, it's like Robin Hood.
The Robin Hood.
Steal
of the
from the
sea.
rich, take to the poor. But it's like one whole giant rave party. Imagine it's just like you go down there, it's just a whole bunch of like flashing blue, green lights, like The sea walnut in particular has incredible potential, and I'll touch on it a little bit more, but it is often used as like a model animal. It is used as a model animal for future bioluminescence studies. Yeah, so you can look at them to be like, hey, what are these other glowy monsters doing? And yeah, that's it. That's all I have for the ctenophores, or the lovely comb jellies, for now. We will talk about them a little bit more in the safe zone.
Well, you kind of stole my thunder with the whole regurgitate some acid to digest your food before you want to eat it.
Fuck!
But join me for the fireflies, which are in fact not flies, they're beetles. And being a beetle means that they have metamorphosis from egg to larva to pupal to adult. Before being able to fly, they are like the typical ground-dwelling beetle, rather unextraordinary to me. Just a beetle.
They're just beetles.
But once they reach their adult phase, they into a firefly with a glowing butt.
Love the glowing butts.
But as a larva and pupal, they are voracious predators. They are hungry, and they eat literally anything and everything. They inject their prey with a paralyzing liquid using their mandibles.
Oh, I feel like that's worse.
You gotta hold them down first.
Yeah, I feel like that's more... that's terrible.
The grip.
The grip.
Then they secrete an acidic digestive enzyme to soften it up a bit before, they eat.
Gotta make it a little bit easier to get down.
A little easier on the stomach.
Just slides right through.
Ew. They also produce a particularly smelly and distasteful toxin when they're munched on. So pretty quickly, birds and insects learn they're not hungry or they're not tasty.
Okay, so don't eat them. Noted.
So do you call them fireflies or lightning bugs?
Fireflies.
I would have considered both of them. I didn't really think. You're having a stroke trying to talk to it. I think I've grown up calling them both, and I don't think I would really favor one side or the other,
I've never called them lightning bugs.
Oh, really?
Ever. I feel like that's a northern thing.
Oh, what an insult. You calling me a northerner?
Yeah. Well, you said you use both. Fireflies? It's definitely fireflies.
I mean...
Say a Texan. Fireflies.
What about lightning bug?
Oh, shit. That's good, too. Lightning bug. Well, okay. All right. I see it.
All species of fireflies are capable of bioluminescent, but not all individuals do. To make it super cute, each species has their own unique blinking, signaling system.
Like a Morse code type shit?
Yep.
Nice.
And it can be broken down into 3 categories. So you have a daytime firefly, which are active and glow during the day, and they sleep at night. You have the flightless glowers, which what you would consider, a normal-looking beetle, are often the females. They don't need to fly because it's the man that needs to do all the work.
Oh, yeah. They have to come to them.
She can glow as well as the flying nighttime fireflies, which also considered lightning bugs. It's what you would most likely think when you glow at night, or what you see when you glow at night. And the flightless glower needs to be able to communicate with the man because the way that they use their lights is that the more ornate and impressive your blinking pattern is, the more chance you have with the lady.
Oh.
And if she likes you, she will turn on her light and she will signal back to you, I choose you.
Recording.
So, unlike us, insects do not breathe with the whole lung system. They breathe subcutaneously, which is a fancy word for breathing through your skin, like amphibians do.
Like froggies.
Frogs. So oxygen passes through the crunchy exterior of the insect and is diffused right into the blood flow. Fireflies have an organ dedicated to controlling the amount of oxygen that they breathe in through their skin and allow it to mix with the luciferin. And the luciferase is kind of hanging out, and if the bug wants to blink, he kind of breathe in a little bit, add more oxygen to the mix, and it will, make the flash. It also uses nitric oxide, which breaks down really quickly with oxygen. So when they breathe in, the chemical reaction is super quick, and that's why the light is not a continuous bioluminescent glow.
Damn, so rather than getting knocked like it was with the sea sparkles, it's more of they are in control of it, and they can literally breathe in, and that's what's causing it to happen. It's not like a deformation or anything of them.
Yeah.
Crazy.
Cool. So since the chemical breaks down so easily, the firefly can control the speed, the intensity, and the pattern that he wants to do. Isn't that so cool?
That is super cool, actually.
So that's really all I had about the fireflies. They unfortunately did not make it into the safe zone, but do not fear because we have a shroom and a ctenophore.
We do. To begin, I want to talk about the sea walnut, or the Nemiopsis lady.
Beautiful name.
Yeah, I thought so too. Yeah. So we know that the sea walnut can produce the ctenophores that we were talking about a little bit earlier. And we've learned that they're beneficial for the deep sea creatures, but how about us? Are they useful for humans? Well, scientists are looking at the sea walnut to figure out how exactly they are able to produce this magical glowing chemical. The goal would ultimately be to replicate this process in a lab in order to create these numerous glowing compounds that can then be used in a bunch of different medical fields, both in biochemistry, biomedical, all of them. So we would also be able to introduce those genes that produce the ctenophores into our cells, and this will allow us the opportunity to better understand that particular cell's behaviors and response to stimuli, because you'll be able to see it clearly, right?
So you're telling me there's a chance I can glow?
Yes.
All right.
Yes. And it works really well, actually, because the building blocks of ctenophores are some of the same amino acids that are in all of us. So it's not like a completely foreign thing coming into our bodies or into our cells. There are similarities, some of those same proteins, those amino acids, all of that.
It's meant to be.
It is meant to be.
Or else it wouldn't have worked.
Right. So there is some potential. And the glow that is also produced by these can be used in a few different tests, like calcium monitoring in live cells or tissues. It can be used in reporter gene assays, and it can even be used in drug screenings. Ooh, yeah. Well, so maybe not all good. That's about it. They can utilize the process in which they can create this coelenterrazine and apply it to different tests that we use in the medical field. They can also use it, again, to be able to understand how our cells work a little bit better. Mm-hmm. So that's all that I've got for the sea walnut. Not a crazy amount, really, for the comb jelly. And then for algae, really, the sea sparkle does not make it into the safe zone. The only benefit I can immediately think of is the fact that if you are swimming and you are able to then see the outline of whatever predator is about to come to you,
no.
It kind of gives away their location. Mm-hmm. So that's about the only benefit I can think of.
That deserves to be in the safe zone.
Yeah, but for the most part, the pros and cons of the blooms are largely going to be affecting what's under the surface more than what's above the surface.
Gotcha.
What about the shroomies?
So yeah, the fireflies did not make it to the safe zone, but I have more than enough for the shrooms.
Fantastic.
They belong in the safe zone. They could have their own episode, but I'm going to keep it kind of short, focusing on bioluminescence. So I will focus on the fact that edible mushrooms, which include fungi and mold, are very good for your health, gut health, mental health. They can treat illnesses, diseases, and injuries. Most notable for the production of penicillin, which was actually a mold used to treat bacterial infections beginning in World War II.
Yeah, I remember being so disturbed when I first learned that we were making stuff out of mold. Mold. But honestly, if it works, it works.
Yeah, so what ended up happening was a scientist left for vacation and came back to see that his petri dish was growing mold on it, but this mold seemed to be preventing the bacteria from growing. And so through other tests, he learned that it can be used to eliminate strep, staph, and septicemia.
Septicemia?
Yeah. Which is
everything septicemia?
Blood poisoning from an infected wound. So that's what it was really...
Oh, like sepsis.
Mass-produced, yeah. For World War II.
Yeah, we're not doctors.
No, we're not.
Yeah. No.
So most people, when they hear shrooms, they think of either the ones you put on top of a steak or the psychoactive ones.
Mm-hmm.
But really only about 200 out of the 1.5 million species of shrooms produce psilocybin, which is that psychoactive chemical that can cause the trips.
The trippy trips.
Yeah. So not only are they good to eat...
and good for your health and diet in general.
They can also make you do some crazy things.
Yeah.
Focusing on the bioluminescence, scientists have figured out a way to use these shrooms by exposing certain pollutants and toxicities. So they will plant them in soil that is suspected to be contaminated by toxins. And the intensity at which they may glow can indicate their health. Right?
Oh, that's cool.
So the intensity of the glow is used to determine whether or not the soil is good or bad, if it's been contaminated.
So it's an indicator species almost.
Yeah, a biosensor.
Biosensor, yeah.
Mm-hmm. Fungi in general has been found to break down and digest certain chemicals like plastic. That's a big one.
Oh, yeah. I feel like I've heard about that being like a new potential wave to like fight the huge garbage patch or like just the massive amount of trash that we have.
Yeah, that is pretty big.
That's cool. That's significant. Microorganisms are doing that too, other than fungi. Love it.
So just a little bit of shrooms in the safe zone.
Yeah.
I won't go
too much into them. I feel like with shrooms have been used medicinally for
teas
for forever. Yeah, especially on like the eastern side of the world, right? We're just now starting to scratch the surface, I guess.
All right, as we wrap up this special Halloween episode for the Freaky Fauna Files podcast, we want to thank all of our listeners for joining us today. From transient anuses to flashing butts, we hope you enjoyed learning about these glowing fauna, flora, and fungi.
And remember that the adventure does not end here. The next episode is going to be taking place in the Florida Everglades. Florida. We're going deep down into the swamp.
Don't forget to follow us on social media at Freaky Fauna Files and send us an email with questions for our next audience ask at info@freakyfaunafiles.com.
Please send them. Until next time, I want you to keep all of your eyes peeled for the unexpected, and may your curiosity continue to lead you on extraordinary journeys. Thank you for listening, and stay spooky.